Sandeep sir, first of all, thanks a lot for your kind and generous introduction. Welcome to everyone who is there from ASM. Welcome to everyone who is there as a guest today. As you can see, ASM is a body where we are working a lot on material science. Like we are the primary body of material science in India, and we ASM India chapter are among the leading material science people out here on this side of the country. Uh, as I share my uh, presentation with you, if you have any questions, you can please put them in the chat box. You can ask, you can put it as question for everybody, and we will take up the questions as we move along and we come to the end of the presentation. So basically, this is my company, BCPL Ceramics. We have been ISO certified for over 20 years now, and I mean, I'm proud to say that we are among the early ceramic companies to be ISO certified at the turn of the century, 2001. While we do a lot of work on conventional ceramic components, like precision parts for various applications, like pumps or sleeves or high temperature applications, customized shapes. That's one of our core areas. Now we started thinking of how to go further. Like the sustainability is a key thing nowadays, and not because it's a trending buzzword. It's because everyone has belatedly come to realize that if you want to pass on this planet to the coming generations, we need to have an ecosystem where we really are able to pass on something meaningful and not pass on a problematic inheritance to the next people coming in. So when we started working on this, that is when the whole idea of product started coming to us, and that is how we started working on the development. Now, any development needs a very powerful team. So over here, I would like to share our team. Our founder, Mr. AKBC, is present here today. He is also one of the leading governors of Lions. He's a product of IIT BHU and an industry veteran of over 50 years now. He has had the privilege of leading the Indian Ceramic Society as well. Whatever facilities we have today have been created from ground up by him as of now. I handle the more of the technical aspects of the company. I handle the new product development. Our first initial foray was into precision machining, where we were among the first few people in the country. I would say we were among the first people in the country to actually have like 3 or 5 micron tolerance products in India. Later on, we moved on to do turnkey projects of corrosion resistance, high temperature resistance, which is when we came to this thing of when we are working on high temperature projects of how to have sustainable products. And I'm proud to say that after the years of efforts of almost 1.5 decades, we have this whole list of products that are geared towards sustainability. The first one, as Rege sir very kindly put it, Stay Cool is a heat reflective coating for buildings and exteriors. Uh, it's basically a coating. If you apply to the roof of your building, the 95% of the incoming heat will get reflected out. Only 4% will pass on. That also will get reduced further because this coating has extremely high insulation. So apart from just being a reflective coat, it has great insulation properties. It's a walkable surface. Like unlike Western countries, our roofs are used as gatherings, are used for your AGMs, they are used for meetings and everything else. So this coating sustains all that wear and tear and provides 95% heat reflectivity. Now imagine if he reflects back 95% of the heat, how much of AC bill will get saved because the top slab is not getting heated. That's the first product. We have a product called a ZIRPROTECT, which has got high temperature performance. Like it is used in the inside of furnaces where it protects the refractory lining, it increases the lifespan and provides insulation. So if anyone of you is using furnaces, which are high temperature furnaces, I would definitely invite you to try out ZIRPROTECT for your furnace. You definitely will see a performance increase from your furnace. The same product, but now to protect metals, is used in the form of ZIRPROTECT metal, where you have heat conduct carrying chutes, or you have furnace outflows, which is your flue gas outlets, your chimneys, or in some cases high temperature valves as well. They can be protected by ZIRPROTECT metal. DHA 25 is a product that's specifically geared up for the aluminum industry. Now, aluminum industry has flexible chutes for conveying the molten aluminum to the mold where it is being cast. We are the first people in the country at the moment to actually have a ceramic based flexible coating. It works like a base coat and a top coat, and your base coat is flexible and coated onto the fiber. And when the flow is about to begin, you can put the top coat, let it dry, and start the flow. The next two products are ceramic ferrules, which are of course components for waste heat boilers or sulfur recovery operations. These are in formulations up to 1800 degrees. We are trying out a variant where the application temperature can be stretched to 2100 degrees, but that's under development at the moment. And heat retention or thermal storage spheres or balls, they are useful for application up to 1250 degrees. Now, all of these products are geared towards energy saving performance or value addition in terms of saving your furnace cost and carrying more insulation. Now, moving further, this is a typical problem statement. Like for anyone who's used a furnace or a kiln or an oven or hot gas generator or is simply conveying hot air anywhere, the first challenge is how to lower the heat losses. You have got an ambient end at one side, you have got a hot fluid or hot kiln, or you have got a furnace at the other end. By nature, by the laws of physics, heat is always going to travel. Now, can you stop physics? You can't. You can't go against the law of physics. You can't go against the law of nature. The only way to do that is to impede the heat flow, like create barriers for the heat to start flowing out. Now, how do we create that barriers? That is when mankind started working on it. They started developing different products from the crude clay bricks, from the crude clay-based coatings in earlier era. Like if you go to the history of India and China, they were clay-based autoclaves, as we call them today. Then on, as the materials improved, there was a vast variety of materials that was made available. Now, in general, what all materials would be there? Initial days, the early 20s, I'm talking of 1920s, 20s and 30s saw a lot of work on asbestos. They are now banned in many places because unfortunately they are carcinogenic. Rock wool, glass wool is something that is being used in a very common way because it has got very low thermal conductivity. Uh, it has got very low density. So this is where the low conductivity comes in, because the fibers as you lock the fibers, you're creating a void space between them. So the fibers themselves the conductivity of the material might be higher, but overall package has a low thermal conductivity. But the flip side is it has got low density. So if you see common fiber based furnaces or fiber based insulation, you would have a very thick wall. You would need to have 2 feet or more wall to actually have a heat reduction. Again, they are fibrous in nature, so they pose a health concern. As anyone who has worked with them would know, any fibrous based body almost always poses a heat concern for humans. Now, there are vermiculite based products as well. The vermiculite based approach has a little bit of a challenge because there have been cases reported in USA where the vermiculite itself was found to have containing tremolite, which is the most hazardous form of asbestos. Those who want to really research on it can get in touch with me. I can provide you the necessary links to see vermiculite and asbestos and the impact on the health. The last and the safest option is use of ceramic based castables and ceramic bricks. And as you can see in iron and steel industry, in various other industries, castables play a major role because they are convenient to use. They are safe. Like once it's set, it is set. And the third point is with castables, they are rugged. The same is with ceramic bricks. The flip side of using ceramic bricks is they are very heavy. You have a very high heat load when you have to make a furnace from ceramic based bricks. Obviously, if you have a very high heating load, like if you're going to have a big mass of bricks that you need to start heating, it's going to eat a lot into your fuel cost. More importantly, bricks have more thermal conductivity. Like if you see your standard bricks, the ones which are used for lower temperatures, their thermal conductivity is in the range of 1 point something to as high as 1.8. If you progressively go in the lower in the series, I'm sorry, higher in the series, you have got bubble alumina, which is at the other end of the spectrum, whose thermal conductivity is about 0.17, 0.18 watt per meter degree Kelvin. So overall, if you see the way if you have to categorize an ideal insulation material, it would meet these parameters. It should have low thermal conductivity. That means it should offer a very good thermal impedance. It should have higher density than the wools. So we can go for a lower thickness. Of course, it should not be as dense as the bricks also, but somewhere it should have a low density than the bricks, but higher than the wools. The material should not pose any health concerns to installers or the users. This is very important because if your users or the installers are going to face health issues because of the insulating material, that's a big problem. And it should be convenient. Nowadays, everything is based on convenience. How convenient is the product for installation? Can it be installed with ease, or does it require specialized installation? Can it be, does it require a lot of joining of a lot of parts? Like if you're going for a board-based geometry, you need to join a lot of parts together. You have to worry about the joints. You have to worry about sealing the joints. You have to worry about the breakages. And most importantly, you have to worry about the leakages. If it can be cast in situ, that is where the material triumphs, because you can create a continuous wall as long as you want, and if you do it right, it will sustain. So if we define these parameters to be the critical parameters that define a good insulation, let us see how ThermProtect, and this is how it fares against it. The thermal conductivity is between 0.13 and 0.15, which is lesser than the lower end of the spectrum of the bubble alumina bricks, much lesser than any castable, because the lowest conductivity of a insulating castable is 0.3 watt meter per Kelvin. It has higher density than wools. So the density of ThermProtect is 0.65 gram per cubic meter, or 650 kilogram per cubic meter. I'm sorry, I'll restate that because I missed it. The density is 0.6 gram per cc, or 650 kilogram per cubic meters. Your general blanket is in the range of 128 to 164 to 220. So this is almost 3.5 to 4 times heavier than the wool. But for that heaviness, you still have got a very low thermal conductivity. So that trade-off is somewhere matched out, because you would get a lower thickness of coating. You can start out by having 2 mm thickness as well. Now, health concern wise, this specific formulation is formulated without the use of any fibrous materials. There is no fibrous material that has gone into the formulation of ThermProtect. Now, the last question, as we discussed, convenience. And why I keep on harping on convenience, because you see the whole system built around convenience. You have to have food at home, there's Swiggy. You have to watch films at home, there's Netflix. Same way, our categorically we were like, it has to be a versatile material. It should be able to be coated. It should be able to be cast. And if someone has a specific requirement, it should be able to cast and machine into a complex shape. Now, I'm happy to say that we are working with someone from ASM itself. I cannot disclose the name because we have already signed an NDA on making complex shape insulators for a certain project. I am very hopeful about this project taking off really well, and we being the first people in India to make this complex shape of this ultralight material. Now, this brings us to the next part of it. How do we characterize this ThermProtect as working or doing the job? So the basic idea is to have a test assembly and a reference assembly. We subject both of it to a heat source. We start heating both of them and really see how the heat behavior goes. Now let's see how in clarity, how does that work out really? So this is a reference assembly. If you can see my screen, I'm circling this heat source below, which is marked by the triangle, the symbol of heat. You have a base plate, which is a MS plate, and you have a substrate on top. The base plate is made of MS. We have taken a base plate over here so that the heat source heats the base plate. We have the hot phase reading. This is the temperature of the base plate, which is the hot phase reading. And you have the temperature of the top of the substrate, which works as your cold phase reading. Now, one of the role that this base plays is you really have a uniform heating across the surface. So when you're conducting this trial, you have a very good idea of what the hot phase temperature is and what the cold phase temperature is. Now, how does your test assembly look like? Now we coat it. We obviously use a substrate which is coated with ThermProtect, and we put it face down, like your coating is in touch with the hot phase or the heat source or the base plate. Now, as you can see clearly over here, this is a coating of ThermProtect over here that is applied on the substrate. The coating thickness is minimal, 1.5 to 1.8 mm. I'm stating this because when you coat it, there are bound to be some variations, and we have worked to make it very accurate.
Sorry to
Now,
interrupt you,
over
Dev.
here, the same.
Dev, sorry to interrupt you. You have to
Yeah.
go a little bit louder, please.
Okay. Am I audible now?
Yes, yes. This voice we require.
Oh, wow. So I hope the earlier part of a presentation was not Greek and Latin to everyone.
See, initially you were okay, then slowly your voice volume went down. So just keep it up. Okay.
Okay.
Okay. Thank you.
Yeah. How's the Josh? Very high, sir. Yeah. So now over here, if you see this basic, okay, give me a moment here. I'll just change the setting over here. Give me a moment. Please bear with me for a minute as I change the setting over here.
Yeah, please do it.
I'm going to stop sharing for a minute as I change my settings. Please
Yeah,
bear
sure.
with me for a minute.
Yeah.
Okay, can you hear me now?
Yes, much better than earlier.
Vivek sir, can you hear me now?
Yes, yes, I can hear you, and it is much better than earlier. You please go ahead now. You are not able to hear, is it?
Yeah, am I audible now, Vivek
Yes,
sir?
yes, you are absolutely audible. It is much better volume.
Okay, cool. So I will continue.
Yeah.
Is there anything anyone wants to ask from the last part that I covered that was not clear to you? So I can just quickly head back and get it cleared out.
Just a minute. Sandeep, any suggestions you have got?
No, you can continue now. No issue.
Continue. No need to repeat anything. It was just it came from the audience that if it would a little bit louder, it will become easier for them. So please go ahead.
Okay, if anyone has any questions, please reach out to me.
Yes, I would suggest that questions we put on the chat and then they can be asked. So
Yeah.
Okay.
Okay, so can everyone see this? And more importantly, can you see my mouse pointer?
Yes, we can see your mouse pointer and this is visible.
Okay, amazing. Cool. So this is where we are installing the coating. This is a coated sample where it's on the heat, so it's on the base plate. We are heating the base plate,
And as everyone knows, this is your typical heating system. This is your hot face of the lining or the heat source. This is your insulation lining, and this is your furnace exterior shell body, and this is the temperature, the cold phase temperature at the exterior of the furnace. So this is roughly what we are trying to mimic over here. So now what we did was, both the assemblies, we started heating up with the same amount of heat, kept the heating in the same way, and took the measurements for 50 minutes and 70 minutes to see how the hot phase temperature and how the cold phase temperature, how they vary. And then we did a typical time versus temperature graph. Now, how does that look? This is your first 50-minute reading, where this red is the reference piece where there is no coating applied. The blue is the sample coating. You can see that after 50 minutes, there is almost a difference of 100 degrees over here, which means the hot phase of the sample which had the coating as an impedance from preventing the heat from going across the barrier ended up being at a higher temperature because the heat did the work of warming up the base plate. If you see this curve, the ramp up curve, though it's similar, you will see this ramp up curve is far faster and far steeper, which indicates that when you have a barrier to the heat, the entire heat is getting concentrated on heating the base plate, and a very little amount is getting transferred. So you have a very fast ramp up. Now, if you look at the 70-minute curve, also it looks fairly similar. Like if you see over here, round about after 7 or 8 minutes, you've started to get the plateau. You've got a minor rise over here. But on an average, where this system took about 21 minutes to stabilize, this system had stabilized in 11 minutes. So if you see, if you think in terms of furnaces or any other heating application, on a 10-minute earlier stabilization in having a 1.5 mm or 2 mm thick layer, you can imagine the kind of saving this would produce. At the end, when we stopped after 70 minutes, the temperature gap was about 80 degrees. So when we are having a small heat source, a smaller scale version of this, a 1.5 to 1.8 mm is giving you a difference of 80 degrees. We did the same thing for 50 minutes. Over here, we got about a 120 degrees difference. But you can see pretty much the same thing. Like, the curve is far steeper. You're having stabilization fairly quicker than the earlier one. So in both the cases, you can see that, usage of ThermProtect is really giving you a drastic difference. Cold phase is also an interesting phenomena. You see over here that at the measuring time, at the steady state, when we called close to the operations, you almost had a 30-degree difference over that. So if you see your sample phase where you have the ThermProtect applied and the heat going through ThermProtect on the other side of the substrate, versus you have the reference over here, which has no ThermProtect, you will see that the cold phase difference is almost of 40 degrees or 30 degrees. So your cold phase on that system, over a temperature of about 250 degrees, you have a temperature gap of 30 degrees. So this is what you're talking of performance. Like a small coating is giving you this kind of difference. The same thing is over here after 70 minutes. The gap has slightly closed down. It's about 40 degrees. But we are talking of 1.5 mm thickness. So now if we had to really summarize these observations, you can see that if the hot phase curves are compared, the same amount of heat input, the same time period, the hot phase of the coated test sample is going at a higher temperature than your control sample, and the ramp up rate is much faster. This indicates that even the small layer is giving a very high impedance to the transfer of heat from the base plate to the SS plate. And what it really means is, if you have a barrier over there, you're having the heat actually do the work of warming up the plate and not transfer it to the substrate that is on top. In terms of your furnace, more amount of work would be done inside the furnace, warming of the articles, heating of the articles inside the furnace, rather than the insulation eating away into the heat. So this is what we are saying, that it will help in retain the heat inside the heating equipment. It shall help in having the heat come faster. Your ramp up rates would go faster than this. You would have savings on energy due to lesser losses. Like as we saw in the earlier case, your temperature was attained on the steady state was attained in about 11 minutes versus 21 minutes that was taken in the control. You can have more heat work on the components inside than on the insulation because of this. Again, if you see the cold phase, you will have a cooler cold phase. So for now, the trend is that you need to have the cold phase, the exterior of the furnace, to be something that you can touch. So for those kind of requirements, this is an ideal product, because if you use a last layer on the inside of the shell, it will really help in taking away the last bit of heat that goes across the furnace. So coming to the conclusion of this presentation, as we move further, some of the characteristics of ThermProtect, as we would like to share with you. The thermal conductivity is around 0.13 to 15 watt meter Kelvin. The density is 0.65. The density of water is 1. So this is an insulation that will actually float on water. The max usage temperature is about 700 degrees centigrade. So it will work for major applications of furnaces where you're having ovens that are used in the automotive industry for curing of paints, ovens that are used in various other metal processing industries, a back end for various ceramic based furnaces or any high temperature furnaces. They can be used in heat treatment furnaces with the top coat of ThermProtect. So if you use ThermProtect to see the hot phase and ThermProtect as a backup layer, you can see a solid amount of savings over there. The beauty of this is the PLC at 700 degrees is just 1.5%. And LOI, of course, which is the moisture content after you dry it up, is going to be about 0.5 to 1%. So we are talking of various applications over here. The world is massive for the applications of this product. And one of the reasons that we have this, the ASM around, is to look for such applications and create energy savings such that the planet becomes sustainable to hand over to the next generation. So as I come to the end of my talk, I hope a lot of you have a lot of questions. We are going to be hanging around for some time. This is our contact information in case you want to reach out to us after this talk is done. So if you have any questions, if anyone has any questions, I would be happy to take the questions right now. If anyone wants me to repeat any part of the slideshow that they missed out due to some technical errors, I would be happy to take that on as well. So Vivek sir, back to you. And if anyone has any questions, I would be happy to take those questions at the moment.
Sudeep, you can unmute, please.
Yeah, thank you, Vivekji. Thanks, Dev, for your excellent speech. Okay, so I would like, for me, myself, I want, if you could go rush through the slides once more. So, it will be better for me, for me alone. At least, I don't know what about any, no participant has talked about it, but if you could do for me, all the
Sure.
slides, just rush through quickly.
Yeah,
Just go
sure.
one by one so that it will be
Yeah.
better for us. Yeah, then we will take question answers.
So this is more about our team. My father, who is there on this call right now, he's an IITN from BHU and a
Yeah,
veteran.
this was known. This was known. Just go through this thing. Yeah, the slides. No need
Yeah,
to talk about it. Yeah,
yeah. This is the product range.
yeah, yeah. See, the question here is all these products are innovations through any. I mean, how but these products have been innovated by you only, or how is it?
Yeah, this is all manufactured, designed, and tested in-house by us.
And patented also.
Yeah, we are in the process of patenting them at the moment.
Awesome.
Okay. You may rush through the slides right here. Yeah, go ahead, please. Yeah, move on, please.
Mr. Vise,
Yeah,
thank you very much for a very nice presentation. It appeared that it is not coming from an industrialist, but from a professor. Very short
I will
but
take it
very
as a
crisp
compliment.
presentation. Both son and father, you are from IIT. Of course, your father's time it was not IIT. Now, of course, it is called IIT BHU. So first, congratulations for that. I have, it's very nice area. I'm not working in this area, but I would just like to know that they are monolithic ceramic or they are composites. And some of the things, you know, like what we know of ceramics, they are very brittle. Normally, when you they go through these temperature variations, there is a thermal fatigue. So, what is the life of that? First thing, and some of your ceramics that you mentioned can resist up to 1800 degrees centigrade. It's fantastic. So, can they, and they are light. So, are these the same ceramics can be used for space programs? You know that one incident that happened about the accident due to this tiles, you know, which came out. So, can they be used for space programs for re-entry vehicles?
So let us go one by one to what you said. Your first aspect was about the fragility. So any ceramic is going to be fragile. Inherent nature of ceramic is it is fragile. And see, what happens is when you're working as an insulation, now I'll stick to ThermProtect and then come to ZProtect. ThermProtect has been designed for use in applications where you have some inherent protection around it. Like it is on the backup side of your furnace, or if you have an oven, it's going to be on the inside of the furnace oven where you are not going to see any component coming in touch with it. So ceramics obviously are going to be fragile. ThermProtect is also fragile by nature, and it has to be handled with due care, such as there has to be no impact on it, or there has to be no components going on running through it, so that you get the maximum life on it. Of course, we have our own process where we have a top coat on ThermProtect, which makes the surface very rigid, and that increases the life of ThermProtect as well. Now, coming to a second part, you're referring to the, I'm not, I think it was the Challenger tragedy that you're talking about, where we lost an Indian origin astronaut, Kalpana Chawla, I believe. So over there,
Yes, yes.
yeah, over there, what happened was their heat tile actually came off during the launch because of the impact. Now, if you use a coating over there, you have a chance of something similar happening, but because it's a coating, you know, you would probably lose a top bit of it and you won't lose the entire chunk of it. That particular bit of foam that was there, that was installed by hand, and that came out because of impact. So this would be suitable for that. We have worked on a similar application, but I cannot reveal more than that, because you know how it is with such applications. You have to say nothing, keep quiet, but do the work.
I will not ask you to reveal the technicality, but is it glass mixed ceramics, composites?
No, this is basically aluminosilicate based chemistry.
I see. And you referred to some ultra light materials, and you said that you can make complex shapes.
Yeah,
So,
same. We can make complex shapes in ThermProtect.
yeah, you can make complex shapes. And then it came to my mind that for old people, you know, when we go for this dental treatment, there also we are using ceramics, and that is machined by CNC. So how is that ceramic different than what you are talking?
Okay, that's a huge different ceramic. That grade of ceramics is has to be hard, has to be tough, has to be incredibly dense, because that's a dental ceramic is made of zirconium based technology. We make the same material for different applications, not dental. It's a whole different ball game altogether. Ours is insulation, so that's a whole different genre altogether.
But you see, in India, everything is imported. So now we are looking for this import substitutions. So are not Indian companies capable of making that type of ceramics?
There are some Indian companies doing that ceramics, but I'm not too aware of it because it's not a product that we have taken too much attention towards.
Now the last questions, you both of
Yeah.
you are from IIT, and I
Professor Prasad, we have lost your voice.
Yeah, I think the meeting got disconnected.
Yeah, I was just asking that what is the offerings for the students? Because do you offer some programs to give knowledge to our engineering students? Because 10 lakhs students passed engineering, and very few from IIT and BHU. So for these private colleges, tier 1 and tier 2 institutions, what type of, I mean, academia and industry interaction, particularly with reference to your industry, can we have some sort of a interaction?
Definitely, ASM has got very good programs of interaction between industry and academia. I would really invite you to be in touch with Vivek sir, because he will take you through the whole process of what ASM does for industry and academia interaction.
Hey, he's a member of ASM. He's a member of ASM.
I am a long member of ASM, and Vivek Singhal is my student. So,
Oh, wow.
so I know
sir,
that. I was
So
trying to directly connect to you that
Okay.
can we come and visit your R&D center or something like that to just find out some of the areas where we can make some interaction.
Sir, you're welcome to visit us at any point of time.
Thank you. Thank you.
Yeah.
Thank you.
Now, some of you. So now I got a question that, can it be used for boiler furnace tubes? For Silva sir, for boiler furnace tubes, we have ceramic based ferrules that we are doing. I would invite you to share your contact information so we can be in touch with you on that. But on the exterior side of the boilers where you have got heating out, ThermProtect would be an excellent option for protection.
There are some other questions also, but which are no longer visible because we restarted. I will just read out those questions.
Yeah, please.
Okay. Okay. This is from Mr. Vasudev. Can this be used to coat a jacketed vessel to conserve heat? Temperature is around 120 to 150 degrees centigrade.
Definitely. It can be used to coat a jacketed vessel. Now, if your vessel we have to see the location and see the site on how it has to be carried out. Because if your vessel is a little bit exposed to the environment, we'll have to give a protective top coat on the coating of ThermProtect. We'll have to come and visit your site, but it definitely can be done, and you can have some savings over there because of the insulation of ThermProtect.
The second question is how these coatings can help thermal uniformity in heat treatment furnaces. This is from Suresh.
Okay. Suresh sir, if you could turn on your video, maybe I could talk to you directly as well.
Suresh
So
Kanose.
Yeah, hello.
yeah,
Suresh.
yeah. Hi, Mr.
Yeah,
Suresh.
yeah. Good evening, and thanks for such an engaging and informative talk.
Always
We
a
learned a
pleasure.
lot.
Always a pleasure. So to answer your question, see, look at it from the perspective of your how your heat is getting utilized. Okay,
Okay,
if you want the major part of your heat to be going into the components that are inside your furnace.
exactly. Yeah,
The second aspect of heat would go into heating your insulation, and
yeah,
the third aspect of heat would be the wastage from your flue line.
correct.
What we are doing over here is strengthening your insulation in a way that the part number 2, where the insulation takes away the heat, is greatly reduced. So that leaves you with the parts being heated and whatever wastage just goes in the flue.
Correct.
No,
So
I
over
think
here, this yeah, Sandeep sir, you are saying something?
yeah, I think Suresh is asking about the consistency of furnace within
Yes.
the furnace
Within the
with
furnace, how it
by
will come
by
to uniform.
by yeah by improving. I mean by utilizing your coatings.
Yeah.
So
So
Yeah,
I
that
was
is
generally,
yeah.
as per CQN, and currently it is plus minus 14 degrees Celsius for temperature of 900, 920. And for tempering furnaces, it is far maybe plus minus, I think, 10 degrees
Five.
Celsius. So how come that variation can be reduced with these ceramic coatings?
so if you have a stronger insulation, you would have a lesser amount of heat going out through your insulation. That
Okay,
definitely will help you getting more uniformity because, as I said, the three avenues, you're lessening the amount of heat work done in the second avenue. Because when your furnace starts to get a little old, which happens to every one of us,
yeah,
your bricks are intact or your lining is intact, but the space between the lining, that is where the heat loss begins. Now, if you cover the whole
correct,
furnace
correct,
with the coating, you again have a uniform surface which is
perfect, yeah,
which resists the heat transfer. Now, if you've got a 900 degrees, we have to do a double coating. We have to have a base layer of ThermProtect and a top layer of ZIRProtect so that the heat transfer to ThermProtect keeps it below the requirement of 700 degrees. So if you have both these layers, you would see a significant amount of heat, the droppage in the amount of heat going into the insulation. So that droppage will help you get more uniformity.
So do we
okay. So
have
it's a
any
combination of this ceramic, I think ceramic, these custom shapes plus coatings also, right? So as you
No, it would
mentioned,
be both
it
the
has to
coatings. Both the coatings.
both the coatings, yeah. And you just said that it should be strong enough. So by that, did you imply? Sorry, do you imply it is the density wise it should be good?
So when I said
Strong,
strong enough,
yeah,
I was referring to the density of it because when you're
yeah,
using
correct.
a wool, it's very light. But the problem is that your wool is just too light to be used. Like you've got this thick linings.
Yeah,
What we were talking of something intermediate where you don't have something as dense as a brick and you don't have something
correct.
as light as a wool.
Yeah, thanks,
do we
thanks
have any
for
do
this.
we have any study whereby we have seen the consistency to the range of around 1% or so?
No, we are working on that at the moment.
If you could do that, I think that will help you in a business as well as we as a heat treatment operators will be able to do it faster and better.
Definitely. Sandeep sir, I
And
would
of
like to
course,
connect with you offline on this.
okay.
The next question is, what is the covering power of ThermProtect and ZIRProtect? How much coating is required per meter of metal surface and per meter of refractory?
See, that depends on what thickness you are targeting. As a rule of thumb, if you have to go, round about 1 kilogram will cover about 2.5 square feet for a thickness of about 1 to 1.5 millimeters. Now, this is a very rough estimate. It varies from case to case and site to site.
This is for both ThermProtect and ZIRProtect, or
Yes. That is for ZIRProtect. ThermProtect is significantly larger coverage, but it depends on the site and everything else.
these are the questions which got disconnected from the chat. Now over back to Sandeep.
I think
Babura.
we have the,
Mr. Baburao wants to ask a question.
Yeah. Go ahead, sir.
Mr. Baburao, you'll have to unmute, please, sir.
Can you hear me?
Yes.
Yeah.
Mr. Deo, congratulations. This is a very
Thank you.
good informative seminar. You know that I am in the pharmaceutical line. We are manufacturing some certain chemicals, and for preparing the amino chemicals, we are using a lot of steam. One participant asked the question regarding the reactor, and that is I require in-depth information, because sometimes we use various temperature to complete the reaction.
Okay.
Initially maybe 40, 50, then we increase up to 90 or 120. Then again, after completion of the amine reaction, again we reduce the temperature by applying the chilling plant out. So this type of the temperature. So now how we can use your technology for maintaining the temperatures?
So I will actually have to see your reaction to make a better sense of it, because if you have frequent fluctuations,
Yes.
that indicates that you know your process is fairly complex. I'll have to see it to really get an idea of what it is. But
Right.
as a rule of thumb, from our experience, we have seen ThermProtect doing a good job of insulation at lower temperatures as well. Like, you know, for even for a cold temperature, it works really well. So in your case, in terms of cycling, we'll have to see what kind of cycle you have, and then we can really make an educated comment about it.
Okay, fine, good. Thank you.
So what I would suggest is, sir, I will plan a visit to your plant sometime.
Better. That will be ideal for me.
Yeah.
My technical people will participate in a discussion because there are different type of the vessel, different type of the temperature required in various stages. So it is require a lot of information for you to just conclude the final. I mean, what we can do it whether possibilities there or not possibilities there. That is what I want to.
Definitely, I'll be there at your plant sometime next week, sir.
Fine, thank you. Thank you. All the best.
Thank you.
Babura, I have one small request. Why don't you get associated with the ASM?
Yes, definitely.
I'll be happy to welcome you there.
Yes, I'll happy to join your association, definitely.
Okay. Vivek, take note of it.
Yes.
And another request. Another request. Now there is full board of BC ceramic available today. So I have one small request for them. I think Mr. Anil Bise and JC Bise are listening to me. So now we want you to be the corporate member, because they is not listening to us. So we directly come to you and you become our corporate member. That is one thing. And second thing is, we need your blessings for most of the programs. And third one is, can ASM have the official visit to your factory? These are the three requests I have.
Okay, I'll definitely consider your request. It will be my pleasure to get associated with you, because all my life I have been associated with so many other associations, inclusive of Indo-German Chamber of Commerce, Indo-Swiss Chamber of Commerce, and so on and so forth. That will be additional thing I'll have to do, but it will be my pleasure. I'll definitely do it.
Thank you. Thank you.
Yeah, Sudhakar sir, I'm anyways visiting Babura sir's office sometime in the next 10 days. So I will carry the forms with me to make sure that the thing happens.
Right.
So you are otherwise our ambassador also. No problem.
Good.
Dr. Anil Karkhanis, you have some point to make?
Yeah. Can I talk about it, please? Hello?
Yeah, we can hear you. Please ask your question.
Yeah. My question is, you have generalized that all ceramics are fragile. Okay. I will draw your attention that materials like boron carbides and some silicates also fall in ceramics range, and they are used for no less than kind of a bulletproof jackets and other things. So those ceramics are not cannot be fragile. You got my point?
So, sir, I would like to respectfully disagree with you. If
Huh.
you see the working of a bulletproof jacket,
Hmm.
the fragility of the ceramic is used for lowering the energy of the projectile. You have got a first layer, which is the polymeric layer. You have got a
Okay.
ceramic plate. You have got a
Hmm.
second and a third layer of polymeric jacket, and then you have the body vest.
Okay.
What this does is when a projectile or bullet comes in, the first
No.
layer of the polymer acts to do a minor slowdown of the projectile.
Okay.
The second layer of ceramic, when the bullet hits it, it shatters. Now, as you know, as it breaks, the work done by the bullet in breaking the ceramic piece reduces the
Hmm.
velocity of the bullet, and after that, you have the second and third layer of polymer that traps the bullet. Now, over here, the process of the bullet trapping happens because the major velocity loss happens because of the fragility of the ceramics. You have
Oh.
alumina based bulletproof jackets. You don't have a silicate based bulletproof jacket. You have got alumina, you have got boron carbide, you have boron nitride. Inherently, because the work done by the bullet in shattering this ceramic reduces the strength by almost 70 or 80% or more than that, and then it traps in the next level of the polymer that is there. So ceramics are fragile, but this fragility is being intelligently used by the community of material scientists to make the fragility work for us instead of work against us.
Oh. Oh, that's a function as such you are saying.
Yeah, that's the function.
May I
Okay.
add to what Mr. Karkhani was talking about? If I recollect a long time back, the literature is available that if you have a combination of micro and nano composites, it's not just one
Okay.
composite, add two of them, one may be micro, another may be nano, or it may be nano composites, then it behaves like a superplastic material, which has got elongation even more than 100%. So I do not know, but its applications in your jackets and things like that. But ceramics can
So,
as well be a very tough material if you make it for that.
Sir,
Because
we also do yttria stabilized, magnesia stabilized
yes,
zirconia, which are
zirconia
extremely,
stabilized.
yeah, we do that ourselves. We can make hammers out of it, and they will withstand all kind of force. But all said and done, see, look, when you talk in theoretical terms of fragility, it means will a part shatter? Now, metals do not shatter. They deform, they have dents, chips. Ceramics won't just have dents and chips, it will shatter, which is what we call as their friability or fragility.
What happens is that most of the fracture takes place by crack growth. So in your zirconia toughened this material, when you are applying a stress, there is a transformation, and because of that transformation, compressive stress develops, and that
Yes,
compressive stress, it tries to close the clad. That is why they are crack resistant. So I
yes.
think we can develop ceramics, which are as tough as probably anything else. But I don't know. It is not. I mean, we'll have to find out what is the research in this area at the current time.
So right now, the best example you have of a toughest ceramic would be there is a composite that is there. It is extremely tough, but it is what do you call? It is usable enough to be made into useful materials.
one layman's question.
Yeah.
those ceramics fall in chemical engineering. Boron carbides or other, these ceramics are taken up in metallurgical engineering.
Yeah, because though the route of making this available is a chemical route, essentially the behavior of the material is ceramic. And a lot of work that goes into developing them happens, unfortunately, by the ceramic people like us and not the chemical engineers. So if we develop something, that's our property.
No. If generally in chemical engineering, you see a ceramic department. But then these ceramics are taken up in metallurgical engineering. That's what.
Yeah, because that's where the origin of everything happened, right? Metallurgy is the place where everything originated.
Because after all, sir, ceramics are oxides of metals. So metallurgists have a role to play there, probably.
Good. So I have put my contact information over here. I have put my contact information over here. So if in the interest of time, I would request that anyone has questions, please write to us. And some of you, we have had a privilege to interact. Like Suresh sir, I would definitely like to interact more with you. If you can drop a line to us and share your contact information, I would be happy to continue the conversation further.
I'll pass on.
Yeah, definitely. I will have my contacts in the chat. Yeah. Thank you.
Yeah.
Mr. Suresh is from which company?
Yeah.
No,
Mr.
sir,
Suresh?
I'm working with John Deere.
John Deere, sorry.
John Deere, Pune.
Yeah, John Deere, Sanaswadi, Pune. Yeah.
He is a supplier assurance. Suppliers quality assurance, right, Suresh?
Yes, sir. I am working in materials engineering and looking after metallurgical quality.
Dr. Sahai is still working with John Deere?
Yeah, he's with us. Yes, yeah.
Okay,
Professor R.C. Prasad,
yeah.
thank you very much. Professor R.C. Prasad, thank you very much for your inputs. Yeah. And I understand that you are working on your material advantage chapter now.
In fact, I take this opportunity to tell you that we are in the process of finalizing a material stamp as per your proposal. Okay, and I have talked to the school principals. They said that December could be a good time for this. And by that time, we think that this situation also, COVID situation may also get better. Yeah. So let us tentatively put it.
You send us a request so that we can process it.
Yeah,
beforehand.
I will send you a request and I will send you a complete brochure also in just some time to come with the proposal.
Yeah, please.
Yeah, thank you very much, Dr. R.C. Prasad. He is always very, knowledgeable person, and he is always putting up some new points into the technical lecture. So thanks.
We learn from industries, sir. Whatever we learn, practical things we learn from industries. Otherwise, so long as we are in IIT, we are theoretical.
Yeah, but theory is also very important, because unless until your theory is very strong, your foundation is strong, you can't work in industry. So that's also one point. You can't be a successful person in the industry. So your theory also, your foundation has to be always strong. So thank you very much, Doctor. Thanks, Dev, for your nice, very informative lecture. And thank you all the participants. Thanks. Next week, same time, we will have another lecture, and mostly it will be on the residual stress by Mr. Yogesh Keskar from Mahindra & Mahindra, General Manager, Materials. So
amazing.
Thank you very much. Yeah.
Thank you all. I am ending the meeting.
So, Sandeep, today we have got 2 corporate members. Huh? Sandeep?
Yeah.
Today we have got 2 corporate members and 1 material camp activity.
Yes.
Every week I have renewed my membership also. I have sent you a mail.
Yes.